give you 50% of profit.
Okay, let's get started. A couple announcements first. The post-test is Monday or Tuesday in the testing center. Okay, so any time that you can go. It's very similar to the pre-test in terms of length and what it's like. Okay, this is a required element of the course. So without a score on the post-test, you just don't get a score on the third exam. But also, based on your improvement from the pre-test, you can earn a proportional amount of bonus on exam 3. So, so this is based on your improvement. So do your best, okay? Do your best on it. Okay, exam 3 then is next Thursday. That's in the testing center. So many of you are asking me about how can I improve my grade in this class. The exam, all 3 of our exams are worth 15% of your grade. So this needs to be your focus to improve your grade in the class right now. Your focus is exam 3. Exam 3. Okay, so like the other exams, it's worth 15% of your grade. So just like the other exams, I posted a review outline, and also the web work is up. So it's the same kind of deal where you have limited attempts. You'll have till Wednesday night to earn credit, but it'll always be available even after Wednesday night. And then the answers will come up after Wednesday night to help you study. Okay? So I also posted some quizzes from like paper quizzes from previous semester. So if you want to look at those too. So there's a quiz archive. But those weren't quizzes that you took, but they're still great material. Yes, sir?
The post-test Monday, Tuesday, is that this coming Monday, Tuesday?
Yes.
So we've got something on Monday,
3,
Tuesday, and Thursday.
That's right. Either you're going to go to the testing center Monday or Tuesday to take the post-test, and then again you're going to go Thursday next week. So you're going to go twice next week. That's right.
Are we still going to have class on Monday?
Yeah, we still have after today we have 4 more classes: Monday, Wednesday, Friday, Monday. Yep. No classes canceled. Other questions on this kind of stuff? So, yeah, start studying for the exam this weekend, the third exam. Start working on the web work this weekend. So and then like around Tuesday, Wednesday, then hopefully you'll have made a list of questions, and then come talk to me. Come get help at the tutor. So there's the tutor room. Don't forget the tutor room. ECA 216 or Mark's office hours. So study ahead and then get the help you need with questions and just filling in the gaps right before the exam.
Is ECA 216 going to be open over the weekend?
No, it has Monday through Friday hours. Monday through Friday hours. They're posted on Blackboard on the announcements page. I posted the hours.
Is there hours on there too?
Yep, so there's a link to my hours on the left side. My office hours. Yeah. Other questions? Okay, so I'm going to finish up that the workbook check that we started, I think, a week ago. And while we're doing that, you can work on. So now we're kind of putting everything together here. So there's many things in the world that have what's called cyclic behavior. That it's repeating behavior. It goes over and over again. And so the sine and cosine can be used to model many of these relationships in the world where things repeat over and over again. So by transforming the sine and cosine, we can model a certain situation. Okay? So we want to practice that. So as you go through these, here's kind of a guideline. When you analyze, so the goal here is, given the graph, can we write the equation of the graph, or write the function? So key elements: amplitude, or midline, amplitude, period, what we're going to choose, sine or cosine, and then horizontal shift. So you can go through each of those. Start with a blue and then do the red and purple last. So do blue and then red and then purple. And analyze each of those graphs for these things, the midline, the amplitude, period. Do you want to eventually write a sine or cosine? And then horizontal shift. And then with that information, with all those values, can you construct the formula that would graph the graph that you're seeing? So that's plenty to work on while I'm continuing the workbook check. So I'm going to call you up by first name, bring your workbook, and then we'll regroup and talk about these when I'm done. Is your task clear? Just, you know what you're doing? Let me know if you got a question. Just work the whole blue graph, and then the whole red graph, and then the whole purple graph. So, but there you go. Well, I can't show you both, so that's what I'm saying. Do the blue graph, and purple graph you won't be there for a while. Okay, so we're going to start with first name M. First name M. Come on down with your workbook. Hold on a second. Okay, let's see how we did. Let's start with the blue one. So, what's the midline of the blue one?
2.
She wants 2. Agree with that? Amplitude. So here's the common mistake. Student wants the amplitude to be 5. Is it 5? No. Amplitude is? Distance from the midline up to the max. So it's not just the height. It's not just the maximum value. It's from the midline, which is 2, up to the max, and also the midline down to the min, whatever that distance is, which is 3, period. Okay, he said 3 pi. Agree with that? So you got some different ways to find that. Probably easiest on this one is peak to peak, right? That would be where it starts over, or the width of one cycle. So if we want to make this as easy as we can on ourselves, should we pick sine or cosine? For the blue one. Okay? So I heard mostly cosines, one sine. Do you agree with cosine? Because what's the definition of cosine? Horizontal distance from? Not from 3 o'clock position. Horizontal distance from vertical diameter, right? And so if we start at the 3 o'clock position, is cosine at max, midline, or min? It's at the max. This is the maximum horizontal distance from the vertical. And then in the first quarter circle, it goes to min? Not min. It's 0, or midline, right? And then the min, and then back to the midline or 0, back to the max. And that's exactly what this is doing now. Graphing that horizontal distance on the vertical axis means we start at the max, midline, min, midline, max. Max, midline, min, midline, max in terms of horizontal distance. Okay? So, if we use cosine, would we need a horizontal shift? No, because it's doing exactly what the cosine does, which is, again, like we said, max, midline, min, midline, max. Okay, so we're ready to write the equation. And so the general form of the equation would be like A cosine B x plus the shift plus the midline. So this is how our cosine formula can be transformed to model all these different curves. Okay, so let's just start from the beginning. What is A? That's our amplitude, right? That's our amplitude. Okay, what's our shift? There is none, so we'll just get rid of it. What about our midline? 2. So what's left is this value of B. That comes from what? How do we get B? From the period. So when x hits 3 pi, so when we hit 3 pi, what do we want Bx to be? Yeah, so 3 pi is one full cycle of this. Cosine will give us a full cycle when what we put into cosine reaches 2 pi. So when that argument, b times 3 pi, when that argument reaches 2 pi, that will be correspond to our period. So what is b? Solve for b, 2/3.
How did you get +2 again?
So what would adding 2 to the whole thing do? So if we got this, we're outputting, think about this as a horizontal distance, you know, and then we're gonna add 2 to everything. It's gonna add 2 to the output, right? So what will it do to the graph? What's that? No, we're gonna add 2 to every output value. So if you got an output value and you add 2 to it, where do you get? Where's it gonna go? Up, right? Output is the y-axis. So we're going to take every output value and add 2. So what will the graph do? Go up, and so it goes up from 0 as much as our midline goes up, right? So that's the midline. Okay, so it's the blue one. This is the one we wrote, right? So if I graph it black, it should land right on top of the blue one. So does it change to black? Yep, we got it right. Questions on blue? Okay, how about red? Midline. 1.5. Amplitude. 1. period. Okay, so there's some different ways to figure this out. Peak to peak here is not very convenient because, oh, and I should have mentioned here. This axis is, I'm giving you, with the dots, I'm giving you a pi scale, but then it's also showing you among that where the integers fall. You see that? So the gray dots are our key angles on the unit circle. Remember how we did the unit circle with the nice symmetric angles? Those are those gray dots. Okay? And then the black dots are every pi over 2. Okay? So if we wanted to go peak to peak here, it's kind of hard to pick out, where we're starting and where we're ending. So is there another way to get the period from this? Anyone? Start at 0. Here?
No, a full cycle.
Full cycle. Okay, so we could do that. Did you have an idea?
Yeah, I was gonna say what the first pi over 2 is. You know what I'm talking about? The first pi over 2 is.
This one here?
Yeah, put a mark there.
Yeah.
And put another mark where the over by this might be a wrong way to do it, but over by the 8. So see where the other integer is?
Here.
Yeah, and then you can see that there's 1, 2, 3 periods there.
Okay.
And then see where I'm going with that?
Yeah. So he's saying so these two places are places we know what the x value is. What's the x value here? The input. Pi over 2, and here? So 2 pi plus pi over 2, whatever that is, right? So is that 9 pi over 2? No. So it's 5 pi over 2, right? This is 4 pi over 2. So 5. So from pi over 2 to 5 pi over 2. Is that what you're saying? And how many periods is that? Good. So we could go 3 full cycles. Takes. So that's 1. So this is 1 pi from here to here, and then 2 pi. So basically 2 pi gives us 3 cycles, so what would 1 cycle give us? It'd be 2 pi over 3, right? So we're going to take this distance 2 pi and break it up into 3 equal pieces. Each one will be the period. So 2 pi over 3. I like it. And that would be the same as if we were to pick off this value right here. Did you see that dot? That's the first key angle after pi over 2, which is what? 2 pi over 3. 2 pi over 3. Okay, sine or cosine would be easiest. Sine. With shift, or with sine, do we need a shift? So does this follow exactly the sine pattern, starting at 0? Yeah, because sine is vertical height. What's the vertical height at the starting point? 0, then 2. Max. Back to 0. Then min. Back to 0, and that's what this is doing. Or midline or 0. Max. Midline. Min. Midline. So we don't need a shift. So the blue one is following exactly the pattern of cosine starting at 0, and the red one is starting exactly the pattern of sine starting at 0. So we won't need a shift on either of those. Okay, so let's give this a shot. So again, it's going to be a sine. We won't have a shift, so we'll just go right to bx plus m. So let's do m first. What's m? 1.5. What's a? 1, or just nothing, right? Okay, or no coefficient. So then we're left with, if the period is 2 pi over 3, can we figure out what b is? Okay, so now our period is 2 pi over 3. what should the argument reach when our input reaches 2 pi over 3? 2 pi. So sine, one full cycle of sine is 2 pi. So when that argument hits 2 pi, x should be hitting our period 2 pi over 3. So that's what that equation says right there. So we can solve for b. So b is 3. So we'll put that there. And I think that's everything. Is that everything? So I'll make it black. It should turn the red one black. Got it. Okay, questions on the blue or the red one? Finding the equation given the graph.
You dropped the pi, right? Like you had the period of 2 pi over 3, but then the answer is just 3x.
But b is not the period, right? The equation is b times x. B is not the period. B is this number that relates to the period. And so I took the period here in order to find out what b would be. And that was the solving process here. And so when I solved for b, I got 3. And so that's the value in the equation b. Make sense? Other questions? Okay, how about the purple one? So let's, now I'll set you loose. Now that you've seen a couple, let's do the purple one and see if you can write it both as a sine and as a cosine. So see how you do on that. Okay, work with somebody else. Take about 5 minutes to work on the purple one. Try to write it both as a sine and a cosine. But still, you're going to start with this info here. Go. Sure. Okay, compare with what you got with someone around you. See if you agree with someone around you in terms of what you've done so far. Yeah, sure.
It could be sine shifted forwards or cosine shifted backwards, right?
In terms of the way that we talked about it, the way that you just said it is a little confusing. Well, wait till shift to the end. Because yeah, so this is not shifting forward. And that's what we talked about last week, or maybe Monday or something, or Friday. We'll go over it again. Okay, did you figure out the midline? I heard negative 0.5 and negative 1. Most people are saying negative 1. What's the max? 3.5, the min? Sorry, 2.5 is the max. Negative 3.5 is the min. Halfway between, negative 1. Okay, amplitude. 3.5? 2.5. We good? Okay, so period. What is the period of this function?
4 pi.
What's that?
4 pi.
How did you get 4 pi?
Basically, I just did half of a full cycle.
From where to where? Yeah.
And times
How did you see half of the cycle from where to where?
from the top,
Here?
yeah, to the bottom. There you go.
Okay, so this is pi over 2. And again, 5 pi over 2. So how many pi is that?
2 pi.
Yeah, so this is 1 pi, 2 pi. So each of these 2 dots is 1 pi. So pi, 2 pi. And that's half of the period. So the whole period is 4 pi. Okay. So we'll start with sine. So we got A sine B x. I'll start with plus 0 plus m. Okay, so I got, what do we know so far? What's m? Negative 1. How about a? Oh. What about a? Try again. 2.5. Okay? And then b we're going to get from the period. Again, let's go through it again. So, when we hit 4 pi, when x hits 4 pi, what does the whole argument need to reach? 2 pi. The whole argument needs to reach 2 pi. That's one cycle of sine. So we're asking what value of b gets us to 2 pi when x hits 4 pi. So what is it? 2/4 or? Just going to be 1/2, right? Afraid of that. Okay, so we got b is 1/2. And the last thing left is to figure out the shift. So let's go ahead and graph this. Whoops. What happened? What's the midline be? Negative 0.5? So whoever said that was right. Someone did say that. Was that you, Simone? Okay. And the amp is 3. It looks like we got it now. So the midline, let's fix it. Midline is negative 0.5. And the amplitude is? Okay. So we got everything except the shift. We're using sine. So here's sine. So the midline's at negative 0.5. So the green one is a sine, and you see it follows the normal pattern of sine. Starts with the midline, goes up to the max, midline, min, midline. Okay? So the question is the angle greater or less, the angle of our curve, the purple one, is it greater or less than the angle of just plain sine? Less, okay? So if the angle is less, is it oh, you got me confused. I don't know what I'm talking about. How did we say this? No, it's not slower if they're going the same speed. So,
It begins at lower than a 3 o'clock position, so it begins at like a 5 o'clock position. So it's starting behind.
okay. Is it starting ahead? Okay, that's the question. Is it starting ahead or behind? So for increasing angle, is it ahead or behind? So let's start down here actually. Is it ahead or behind? Which one starts and transpires first? Purple, ours. So in terms of angle, ours is ahead. All right? So is that a greater angle or a lesser angle if it's ahead? A greater angle. So are we going to add or subtract? We're going to add. Okay? So adding to the angle means it's a greater angle, so it's ahead. So the question is, how much ahead is it? So we look down here. At when y is negative 0.5, and we say, what angle ahead is it? How much ahead is our purple one than the green one? Pi over 2, right? The black dots are pi over 2. So we're going to add what to x? Pi over 2.
How did you get that?
So here's where sine actually starts. Ours is starting this much ahead, right? Yep, and so what angle ahead is our purple one than the green one? Pi over 2, this distance right here, see? So now when I graph it, they should be in the same place. Got it. Okay, what about as a cosine? What about as a cosine graph? So again, we'll make the shift 0 and do cosine. So the green one is the actual cosine, and the purple one is the one we're trying to write as a cosine function. So okay, that's the best I can do. Blotted stuff out. Okay, so no, I don't know what to do here. There we go. Okay. So the green was our cosine. So the one we have, is its angle lagging behind, or is it ahead of the green cosine? In terms of increasing theta. So as theta goes by, which one comes first, the green or the purple? So green starts first. True cosine starts first, and then purple comes later, right? So the angle for the purple one, if it's coming later, is it a lesser angle, or is it a greater angle? It's a lesser angle, right? It's a lesser angle because it's trailing behind the green one. The green one first, then the purple one, right? So green one first, then purple one. So its angle is trailing behind. So we're going to add or subtract? We're going to subtract. How much are we going to subtract? Yep, so again, pi over 2. So the purple one's lagging behind pi over 2, so it's behind by pi over 2. Same place. Okay, questions on that? Does it make...
Say the horizontal shift is pi over two.
Yep, so for the cosine, it's pi over 2 to the right. We're shifting pi over 2 to the right.
Would you right to the right, or would you want us to write
Yeah, as a value, I guess the shift is the shift is positive pi over 2, because if it's shifting to the right, it's positive pi over 2, and that's because we're behind by pi over 2. Does that answer it? All right, other questions on this one? Okay, so opposite task now. I'm going to give you. Turn that off. I'm going to give you the equation. There it is. You're going to sketch the graph. There's the equation. You sketch the graph. See if you can do it. Okay, I'm going to make a round for just questions on previous examples or this one. If you've got a question, you can ask me. Yes. Yes. So when you're working with the period and the p-values, forget about the shift. All you need to know is p is 2/3 times x. I knew you were thinking the right thing. Let me put your bullet list up there. Okay, so should have gotten the midline was -2 and the amplitude was 1/2. We good there? And from those, you put those together to get your max and min. So let's draw just a little channel here. So midline -2. Okay, so we know that's going to be the midline. And then what will the maximum value reach? So from the midline would go up high, high to get to the maximum. 0.5. So what's that value? -1.5. And what about the minimum? -2.5. Okay, so our function's going to live here. That's going to be the maximum, and this will be the minimum. So you can start by kind of drawing this channel, this horizontal channel. The graph will be in there, okay? Period. Period comes from? Which of these values do we get the period from? The 2/3, right? And so what do we say? We say that what value of x is going to make the argument equal to? So now we know b, and we're solving for the period. So it's the same idea, but we've got something different, and we're solving for the period. So you should get, from that, you should get 3 pi. So the period's 3 pi. So what I suggest is sketch it without the shift first. Do the sketch without the shift and get a good idea, and then apply the shift. Okay, so how we know the period's 3 pi. We know it's going to live in this channel here. So how do we sketch it? What do we do with the period to help us? How are we going to have some benchmarks in here, some reference points? Divide by 4, right? One cycle is like going around the circle. Most conveniently, we want to look at every fourth of the circle. So 3 pi over 4. Do you know which angle on the unit circle is 3 pi over 4? So is it in the first quadrant? Is it in the second quadrant? And it's the one in the middle, right? So here is our 3 pi, that's 1/4 of the period, 3 pi over 4. So there's different ways to get these quarter intervals, however it makes sense to you. So now for the next one, you could go back to your original and divide by 2. That will get you to halfway. What will that be? 3 pi over 2, right? Okay, and then, so now we've got the last one. So again, you could take 3/4 of this, or you could take this one and multiply it by 3, or you could take the halfway and add 1/4, whatever makes sense to you. So we've just got to get this 3/4 mark.
For the amplitude, if it says 1/2 in the equation, why is it -1/2?
The amplitude is 1/2.
Yeah, but our,
The midline's at -2. So from the midline we go up 1/2 and down 1/2. Got it? All right, so then we want this, I'm going to go, from here we need to go another 1/4 of 3 pi, or 3 pi over 4, which takes us right here. No, where does it take us? Yeah, right here. Okay, so we broke up the period into 4 intervals. Now we're ready to go. Without the shift, cosine does what? I'll go as fast as I can. Starts at the max, then to the midline, min, midline, that's cosine. So now our angle is greater. Does that mean that our angle is ahead or behind? It's ahead, right? It's ahead by pi over 3. Is ahead to the left or to the right? to the left, right? It comes first. This angle's ahead, it'll come first for increasing angle. So we're going to take all these blue points, I'm going to shift them to the left, pi over 3. So here's shift over to here. I'll do this in red now. Shift over pi over 3, right there. Shift over pi over 3. Shift over pi over 3. Shift over pi over 3. Nope. Shift over pi over 3. So now we can sketch it. Something doesn't feel right here. Something's not right. Anyway, sorry. Something like that. So now if I graph it, got it. Okay, so definitely start studying for your exam. Written homework Wednesday. You could start working on that too to study. And then don't forget the post-test Monday and Tuesday, or Tuesday. Have a nice weekend. If you have questions, I'll stick around if you got questions about this. You too, sir.
What about the bus thing?
The what?
The bus thing you said?
The bus.
Yeah. No, the bus.
Post-test.
Yeah.
Monday or Tuesday.
What's that?
Remember the pre-test?
Yeah.
It's the part 2. Pre-test and post-test.
Oh, so
Very similar.
We should take it. Like,
It's required. In order to get your score on exam 3, you have to take the post-test.
is there any bonus? Like,
Yes, depending on your improvement. I said all this at the beginning. You were here.
Yeah.
All at the beginning. I
No,
said,
the class?
Yeah.
No, it was like...
You came late?
Yeah.
Oh, okay. I
Second
thought you were
one,
here.
Exactly.
No, I thought you were here. Anyway, yeah, so depending on your improvement from pre-test to post-test, you can get some bonus on the exam. Okay?
You will post that? All that?
I'm going to send an email out. Yeah, that was the second half of last Friday's. Did you come up last Friday?
But my first name is Y.
I said T to the end of the alphabet, T through Z.
Oh, really?
See if you missed it. Okay.
Last
just-
week?
No, today.
Oh, sorry.
I said T to Z.
Can I give you a
Yes,
chip?
yeah.
Well, I always come up there. I've come there with like running.
Let me turn this off first.
I'm sorry for that.
Oh, no, that's okay.
Every time I always miss.
Like, it's okay.